let's use the graphing calculator to evaluate these quantities to find the area for the left endpoint, the approximated area for the left endpoint. So this is what we're going to do. So type the function second square root of 1 plus x to the third power. All right? Okay, let's get out. Okay, number one. Before getting out of the menu here, notice how the function we're going to work with is under y1. Okay? Now let's get out of here. Second, quit. So this is what you want to do. You want to go, number one, you're going to go vars, and then there's a menu with three options at the top. Go to the second option. That's the y vars, and then in this case, the number one function says function. Well, we are going to call for a function. What function? Well, precisely y sub 1. That is where we type the square root of 1 plus x cubed. So now that we have the list of functions y1, y2, well, notice how we type the function using the y sub 1. Okay, so click enter and then open parentheses and evaluate it at the smallest value, that is evaluated at 0. All right, so 0, close parentheses. Okay, here's where I'm going to go to the menu. All right, so let me add plus the second term. You're going to go to vars, y vars, function, y1. All right, open parentheses and input the second input, which is 0.5. Right, 0.5 or 0.5, it doesn't matter. And make sure to close the parentheses here. All right, plus, let's go again, vars, y vars, enter, y1, again to call the same function, open parentheses, and what's the next value? Is that 1? Yeah, evaluate it at 1, close parentheses, plus, again, vars, y vars, function, select y1, open parentheses to evaluate this at 1.5, close parentheses. Okay, and then let's add plus, what is that? Vars, y vars, function, and call for y1. And then we keep evaluating this time at 2, close parentheses. And well, I don't want to keep going. Okay, the last one we evaluate is at 2.5. So that'll be plus vars, y vars, function, y1 of 2.5, close parentheses, and we're done. All right, we're done. We're good to go, and click enter, and that's going to give us this result, 12.6439. Usually I will carry like 4 decimals. That's what I'm going to do this time. So in this case, this madness here, you don't have to do anything by hand. Use the method that we just discussed to actually do all these calculations for us. That is 12.6439. So now the next step will be, okay, to write down, okay, that equals to 1/2 times 12.6439. And that equals to 6.323. And that's the area, that's the underestimated area. All right. Let me move on to R6. For R6, that's to evaluate the area for the overestimate. That is the picture to the right using right endpoints. Now, be careful because for right endpoints, check this out. For right endpoints, we are going to use, do you agree that this is the right endpoint of the first rectangle? This is the right endpoint for the second rectangle, first right endpoint for the third rectangle, and so on and so on. All right? So we're going to start from x sub 1 all the way to b. Okay, let's go back. Remember, how do we go from f of x sub 1, all the many f sub x's all the way up to f of b. All right? Now, let's set it up. That'll be, well, everything's going to get recorded anyway, I don't mind. So that'll be 1 half, okay, b minus a over n. First of all, let's do the symbolic representation. And that'll be f of x sub 1 plus f of x sub 2 plus, oops, plus f of x sub 3 plus f of x sub 4 plus f of x sub 5 plus f of b in this case, right? Notice how I label again, only the first and the last limit are going to be the a and the b. Everything in between are x sub 1 all the way through 5. Alright, so that'll be, okay, according with our numbers here, that b minus a, we got it over here, that's the 1/2. That's f of x sub 1, that's f of 0.5 plus f of 1 plus f of 1.5 plus f of 2, and finally plus f of 5. I mean f of 2.5. 2.5. Oh, we still add the last one. Let me erase this. Plus f of 3. And close the bracket. All right. This calculation, we're going to do it in the graphing calculator using the same method we did it. Okay, let me follow the steps again. So we're going to start at f of 0.5 and we're going to end up at f of 3. Okay, let me clear everything here. Okay, again, let's repeat the process. Okay, vars, y vars, function, select y1, evaluate it at 0.5 or 0.5 plus vars, y vars, so vars, y vars, function, y1, and evaluate that at 1, close parentheses, every time you finish an evaluation, plus vars, y vars, function, y sub 1 again, and in this case, how about, evaluate it at 1.5, close parentheses, plus y vars, vars, then y vars, function, select y1, and then evaluate that at 2, okay, plus, what's that, vars, y vars, function, y1, evaluated at 2.5, and lastly, another one, vars, y vars, function, and y sub 1, select y sub 1. Oh, I forgot to add the plus sign. Okay, that's plus first, and then that's going to be again. Okay, let me repeat the vars, y vars, y sub 1, and then evaluate this one at 3. Be careful when doing all these calculations. Like over here, I almost did a mistake of not putting that plus sign because we're pressing a lot of buttons here and there, and it's very easy for us to do a silly mistake here, right? So that'll be 16.9354. All right, 64. That'll be 1/2 of 16.9354, and then divide that by 2. I'm going to round this to 8.468. All right.